Now we'll move on to standard 2, trigonometric equations and identities. Question 1. We're given that cos of x is equal to 2 over root of 13 and x is in the fourth quadrant. We are then asked to find the values of the two trig ratios. Let's start with part A. Tan of x minus 540 degrees. That is basically tan of x minus 3 pi, right? Since the period of the function y equals to tan of x is 180 degrees, this is simply equal to tan of x. Tan of x is equal to sine of x divided by cos of x. So now we need to find sine of x. Sine of x is gonna be plus or minus the square root of 1 minus 2 over root 13 squared. Since x is in the fourth quadrant, sine of x is negative. So simplifying what's inside the square root, we should get root of 9 over 13 or negative 3 over root of 13. Thus, plug back in. Numerator, negative 3 over root 13. Denominator, 2 over root 13. You will get negative 3 by 2. Part B. Cosecant squared of 2x. Cosecant, that's 1 over sine. So this is 1 over sine of 2x squared. Sine of 2x, that is 2 sine x cos x. We found the values of sine of x and cos of x. Sine of x, that is negative 3 over root 13. Cos of x, that is 2 over root 13. So, simplifying everything, we would get negative 13 over 12 squared, or 169 over 144. Question 2. You're given that cos of 8 degrees is equal to m. Find the value of cos of 53 and tan of 4 degrees in terms of m. First item, cos of 53 degrees. That is cos of 8 degrees plus 45. So we're just going to use the compound angle formula. Cos of 8 degrees, that is m. Cos of 45, root 2 by 2. Sine of 8 degrees, that's going to be the square root of 1 minus m squared. Sine of 8 degrees is positive. Sine of 45, that's root 2 by 2. So you can leave your answer like this, or if you prefer some elegance, you can also factor the root 2 by 2 out. Tan of 4 degrees. 4 is a half of 8. So we know that we will have to use the compound angle formula, double angle formula somewhere. There are various ways to go about this. I would personally do tan of 4 degrees is equal to sine of 4 degrees divided by cos of 4 degrees, because it is simply easier that way. Now moving on to tan of 4 degrees. Tan of 4 degrees, notice that 4 is a half of 8. So we can use the double angle formula for tangent. Notably, tan of 8 degrees is equal to 2 tan of 4 degrees divided by 1 minus tan of 4 degrees squared. So tan of 8 degrees, that is going to be sine of 8 degrees divided by cos of 8 degrees. Sine of 8 degrees we found earlier. Cos of 8 degrees we are given. And now we have a quadratic equation in terms of tan of 4 degrees. Multiplying everything by -1 because I hate dealing with negatives. And now we have to solve this equation for tan of 4. So tan of 4 degrees, that is going to be -b plus or minus square root of b squared minus 4ac. This is quite intimidating. Let's simplify this a bit more. Divided by 2 times all of this. And we're down to -1 plus or minus square root of 1, m squared plus 1 minus m squared. So 1 over m squared divided by 2, the square root of 1 minus m squared divided by m. Since m is since m is positive, we can simplify this as -1 plus or minus 1 over m divided by this guy. Tan of 4 degrees has to be positive. That means we gotta take the positive sign up here. So the final answer will be something along this line. If you want to simplify it further, you don't have to, but it looks better. You are more than welcome to do so. And that's the end of the question. Moving on to question 3. In part A, we're asked to express cos of x plus root 3 sine of x in terms of r cos of x minus theta. So, using the compound angle formula for the right-hand side, we have the following. Sine of x, sine of alpha. Now we're going to match the coefficients of sine of x and cos of x. That gives us r cos of theta is equal to 1, and r sine of theta is equal to root 3. To find the value of r, we're going to square both equations and add them together. And the reason is because we know that cos squared of alpha plus sine squared of alpha is equal to 1. Since r is positive, r is equal to 2. 2 cos of alpha is equal to 1. Cos of alpha is equal to 1 by 2. So alpha is going to be pi by 3. Therefore, cos of x plus root 3 sine of x is equal to 2 cos of x minus pi by 3. Moving on to part B. We now have to solve this equation. Notice that it is very similar to what we just proved in part A. In fact, all we have to do is replacing x over here with 2x. Now we have to solve this equation. When in doubt, sketch it out. Cos of something equal to 1 by 2. The first root is at pi by 3. The second root will be at negative pi by 3. So x is equal to pi by 3 plus k pi, or x is equal to k pi. Refer back to our domain from 0 to 2 pi. The roots will be 0, pi by 3, pi, 4 pi by 3, and 2 pi. This is question 4, where you're asked to prove an identity and then to use it to solve the resulting equation. So let's start off with part A. There is a lot going on here. So let's take it one step at a time. On the exam, this can easily be a 6-mark identity question. Step 1, pick a side. Would you like to work with the left-hand side and simplify it? Or would you like to make a complicated mess from cos of 2x? There's only one rational answer. Step 2, how are we going to simplify this? There are a couple identities that I would like you to keep in mind. 1, sine of x plus 180 is equal to negative sine of x, and likewise, cos of x plus 180 is equal to negative cos of x. 2, sine of x is equal to cos of 90 degrees minus x. Of course, you can always derive these formulas using the compound angle formula. But if you have these at your fingertips, it will make your life a lot easier. So, let's have a look at this. 234, we can say that 234 is 54 plus 180. The reason why I decided to split it like this is because 54 plus 36 will give you 90. So we can also write the denominator cos of 36 degrees as sine of 90 degrees minus 36 degrees. Second term, sine of x minus 90. Sine of x minus 90, that would be sine of x cos of 90 minus sine of 90 cos of x times cos of 90 minus 2x, that is simply sine of 2x. Downstairs, we have sine of x. Going back to the first term, sine of 54 plus 180, that is negative sine of 54. Downstairs, we have sine of 54. Second term, cos of 90 is equal to 0. Sine of 90 is equal to 1. Sine of 2x, that is 2 sine x cos x, divided by sine of x. So now we have 2 cos squared of x minus 1, famously known as cos of 2x. End of proof. In part B, you're then asked to use this identity to solve the equation. So I will replace the first two terms with cos of 2x. Cos of 2x, that is cos squared minus sine squared. The reason I decided to go with this one is because a squared minus b squared is equal to a minus b, a plus b. We have sine of x minus cos of x, so we should be able to factorize the left-hand side completely. Cos squared minus sine squared. Cos of x minus sine of x. Cos of x plus sine of x. Minus cos of x minus sine of x equal to 0. Factor this guy out. We then have this. This equation is equal to 0 if and only if either this is true or this is true. Cos of x equals to sine of x when tan of x is equal to 1. For the second equation, we can use the hint. For the first one, x is equal to 45 degrees plus k180, where k is an integer. For the second equation, x plus 45 is equal to 45 degrees plus k180, or is equal to 135 plus k180. Oh, sorry, k360. First equation is solved, keep it like that. The second equation, x is equal to k360. And the third one, x is equal to 90 degrees plus k360. Now, pay attention. Notice that sine of x is in the denominator of the identity. So for us to use the identity, we must make sure that sine of x is not equal to 0. Sine of x is non-zero if and only if x is not a multiple of 180 degrees. So let's just first write down all of the solutions between 0 and 360 from the three families of solutions we have here. 45 degrees, 225 degrees, 0, 360, and 90. We cannot take 0, we cannot take 360. They are all multiples of 180. Thus, x has to be 45 degrees, or 90 degrees, or 225 degrees. And those are the three solutions that we can accept. Question 5. This is a rather fun question on compound angle formulae. So, let's get started. Part A. Part A is pretty tame. All you gotta do is a bit of brute forcing, and you shall get to the final answer. Sine of alpha plus beta. Sine of alpha minus beta. Cos of alpha plus beta. Cos of alpha minus beta. These terms are gone. These terms are gone. So you're down to this divided by that. Cos beta is gone. The 2's are gone. And we have tan of alpha. Part B. You're given that A and B are both acute, and sine of A minus B is negative root 3 by 5. Oh, no, sorry, negative 3 by 5. So, cos of A minus B is gonna be plus or minus the square root of 1 minus negative 3 by 5 squared. And that would be plus or minus 4 over 5. The question now becomes, is it a plus or a minus? A and B are both acute. Sine of A minus B is negative. That means A minus B has to be in the fourth quadrant. That also means that cos of A minus B is positive. Therefore, we will take the positive root, and the final answer is 4 by 5. Part C. We are now given that cos of A plus B is 7 over 25, and tan of A plus B is 24 over 7. What does it have to do with parts A and B? Well, notice that we have sine of A minus B already. We have cos of A minus B already. We have cos of A plus B already. And we can also find sine of A plus B, aka all four identities that appeared in part A that would allow us to find the value of tan of A. So the question becomes, 1. How do we find sine of A plus B? That's simple. That's going to be tan of A plus B times cos of A plus B. So 24 by 7 times 7 by 25. That'll be 24 by 25. 2. How do we find tan A? Well, tan A, that is going to be sine of A plus B plus sine of A minus B divided by cos of A plus B plus cos of A minus B. Sine of A plus B, that's 24 by 25. Tan of A minus B, that's negative 3 by 5. Cos of A plus B, 7 by 25. Cos of A minus B, 4 by 5. Upstairs, we are going to have 9 over 25. Downstairs, we're going to have 27 over 25. So, tan of A is 1 by 3. We are also given that tan of A plus B is 24 by 7 and is equal to tan of A plus tan of B divided by 1 minus tan A tan B. In other words, 24 over 7 times 1 minus tan A tan B is equal to tan A plus tan B. This is a linear equation in tan of B. So we can solve this guy readily. Negative 8 over 7. So we'll get 15 over 7, tan of B on the right hand side. On the left hand side, we have 24 by 7 minus 1 by 3. 72 minus 7, 15 by 7, tan of B. So tan of B is therefore 65 by 21 times 7 by 15. 13, 5, 3, 1, 3. So 13 over 9. And that is the end of question 5. Welcome back to question 6 on the unit test. We are asked to solve this nasty looking equation. So, the first question that you should ask yourself, how do we simplify this guy? And you're given a hint. Sine to the 6 plus cos to the 6 is sine squared plus cos squared. Sine to the 4 minus sine squared cos squared plus cos to the 4. Why is this important? Because we know that sine squared plus cos squared is equal to 1. And we can do a very similar thing to simplify sine to the 4 plus cos to the 4. So you're down to this much. Plug it back into the original question. We would have 2 minus 8 sine squared cos squared minus sine cos. Oh, sorry, that should be a 3. Okay. Simplifying this guy, we'll get 1 minus 3 sine squared cos squared. Plug it back into the original equation. This equation is equivalent to 2 minus 6 sine squared cos squared minus sine cos is equal to 0. And that root 2 minus 2 sine of x must be non-zero. The second equation tends to trip a lot of students. So let's solve the first equation. I'm going to multiply everything by -1 because once again, I do not fancy dealing with negatives. I'm then going to split the middle term up into 4 and -3. Factor it out. Actually, I'm going to factor the 2 out from here. That will leave us with 3 sine x cos x plus 2. That's plus 4, so it should be -1. From there, we have sine of 2x is equal to 1. Or 3 over 2 sine of 2x is equal to -2. Sine of 2x is equal to 1. Or sine of 2x is equal to -4/3. And we know that this guy has no solution. Sine of 2x is equal to 1 if 2x is equal to pi/2 plus k2 pi, or x is pi/4 plus k pi. However, now we're going to go back and solve number 2. Sine of x must not be equal to root 2/2. That means that x must not be equal to pi/4 plus k2 pi, or n must not be equal to 3 pi/4 plus k2 pi. Combining these two solutions, the only values of x that would satisfy would be 5 pi/4 plus k2 pi. In the given domain, from 0 to 4 pi, we have exactly two solutions, 5 pi/4 and 13 pi by 4. Now, if you're wondering how I managed to get to this line, we can just quickly sketch a number line. Let's say with pi by 4, we have 5 pi by 4, 9 pi by 4, 13 pi by 4, 17 pi by 4, and so on. And the same thing occurs in the negative direction. This is x equals to pi by 4 plus k pi. However, x must not be pi by 4 plus k2 pi. So that root is gone, that root is gone, that root is gone, another root over there is gone, and so on. That means that if we take 5 pi by 4 as a starting point, all of the roots will be 5 pi by 4 plus multiple of 2 pi, because we're going to jump 2 pi radians at a time. So that is the end of question 6. Here we are, the last question of the unit test. If you make it this far, give yourself a pat on the back. Because after an hour or maybe 50 minutes work on this test at the pace that I forced you to work in, this is an accomplishment. Let's get started. Part A. If cos of x is equal to 0, show that m is equal to 1. Easy peasy. Plus m plus 5. Cos of x is equal to 0. Gone, gone. Minus 1 is equal to 0. If cos of x is equal to 0, then sine squared of x is gonna be equal to 1. Therefore, the equation now becomes m minus 1 is equal to 0, or m is equal to 1. And cos of x is equal to 0 if and only if x is pi by 2 plus k pi. In part B, now we're given that cos of x is not 0. Therefore, m is not equal to 1. And now we can divide the entire equation by cosine squared. Let's actually do that. Now we are down to 2m tan of x minus secant squared is equal to 0. Secant squared is tan squared plus 1. So the equation becomes m minus 1 tan squared plus 2m tan of x plus m plus 4 is equal to 0, as requested. Now we have to find the values of m so that the equation has 4 distinct real roots for x between 0 and 2 pi. So, a quick recap. 2 pi radians means that you have 2 complete cycles of the function y equals to tan of x. We need 4 distinct real roots. That means, let's say you have one root up here, another root over there, you will have 4 real roots in total. In other words, as long as you have a real m, as long as the equation, as long as you can find real values of k, the equation tan x equals to k will generate 2 real roots for every k. 2 real roots in the interval that we are given. So, all this question is asking us to do is to find the conditions of m so that the value of tan of x is real. The equation needs two distinct real roots for tan of x. This means delta has to be strictly positive. That means 2m squared minus 4 times m minus 1 times m plus 4 has to be positive. And the rest is basic algebra. Minus 1 plus 4, that's plus 3. Plus plus. Gone. And by definition, m is also not equal to 1, so we're good to go. Therefore, as long as m is less than 1 by 3, the equation will have 4 distinct real roots. And that is the end of the test.